Welcome to another episode of Mickey J. Whitehat, the show where we pull apart malware, pull apart executables, pull apart anything and have a look inside. So, if you like to have a look inside, see how it ticks, you want to see if you can find malware, learn some tricks, learn how the malware writers work, or just work out how files work, stay tuned, subscribe, ring the bell, and if you like what you see, drop me a comment. Today we're going to work on an executable that's a bit like one of those Russian dolls. You open it up and inside's another doll, and you open that up and inside's another doll. Whether it's malicious or not, we're going to find out. So here's my situation. I'm using VSDC 6.3 and it's crashing. It's crashing. Every time I try and create a video, it crashes. So I've searched the web and I found out that VSDC on their website, they don't necessarily have easy access to their old versions. So I did a bit of a search and I found this website and I downloaded an older version, 6.1.1. Looks like the right logo, talks about the right supplier, looks about the right size, everything looks good. So I've downloaded this file only to find out that maybe not all is as it seems. So here we have the download. It's got the right name, Video Editor x64.exe, but the icon, it doesn't look like the VSDC setup.exe file. It doesn't look like a traditional exe file at all. If I just view that a little larger, view large icons, as you can see, that's not your normal exe file. It doesn't look right. If I right click on it and I go to my properties and go across to details, there are no details. There's nothing written here. Nothing to tell me who made it, what the copyrights are. Something's not quite right. It doesn't sit right with me at all. So the first thing I'm going to do is I'm going to find out if this is a real PE file or not, and I'm going to use a tool called PEID to do that. All the tools I use, all the links I use, everything will be in the description later. So I pull up PEID and I go and open this file. I link to the file and I go open, and up comes all the information about it. So I can see the entry point, I can see it's designed for Windows, I can see what linker version it used, and down here, this is the telltale sign. So it's using nullsoft PIMP stub, which is a executable self-extracting file, and this is very suspicious. Why would you take an executable from a vendor and then put it inside another executable? Unless you're trying to control how it installed or anything that came along for the ride. So maybe it's time I pump this up through Virustotal. So I've uploaded the file to Virustotal and straight away I've got 17 hits. One of the things that's a little interesting is it does detect it as an NSIS file, which is basically a nullsoft self-extracting file or a scriptable file, and you've also got the EXE designation as well. So the question is this malicious? It says there's 17 hits here. Now I know from previous experience that if you create a tool for extracting files, someone out there is going to make a self-extracting virus, and then one day that's going to get uploaded to Virustotal. It's going to get detected as a virus, and the text and things inside there are going to form the hash to say yes, it's a virus. And then you'll start getting false positives on others that have used the same compression technology with the same tags and hashes, and therefore this may be a false positive. So we start to have a bit of a look here. So looking at this, you got add load, unsafe, bundle installer. I'm starting to think maybe not. I'm starting to think this may actually be malicious. We got all sorts of words here indicating that it downloads something, downloads ads and things like that. So it's highly likely they've downloaded the original distribution file, they've put some other little bundled goodies in there, and then of course distributing it from their own website and making money off the back of whatever you install. So let's put it through hybrid analysis. Up at hybrid analysis, again is potentially malicious, 70 out of 100. That's not a good thing. As we scroll down here, malicious indicators, we can see that it drops a DLL file called itdownload.dll, which is a downloader / or .merlot. So we take note of some of these names because we're going to Google them and find out what this does. As we keep scrolling down, it writes data to a remote process, which in this case is to a temp file. So obviously what's happening is the executable, which is a self-extractor, is then extracting out its contents and writing that somewhere. I can also see that it's playing around with Internet Explorer, which is interesting. I don't expect that at all, so that is a bit unusual. As we go down, it reads the computer name. Okay, so what? We got an IP address URL here that it goes to, and we happen to know that reputation engines have marked this website as malicious. So we're starting to see a bit of a pattern here. This is going to go off and do something malicious with your machine and download ads for you. If we keep going through here, we can see it drops a DLL. In fact, it drops a number of DLL files and also drops that VSDC file. Plays around with some memory. What else have we got? It actually deletes some files as well. So when it extracts out the temp files, which includes the DLL files here, and also it includes the EXE here, it comes along afterwards and cleans up after itself, like any good virus would. And as we keep going down, there's more things it does with files, and more things it does with files. So it's doing quite a few things. It's got 0 bytes in the BSS segment of the PE header, which tells me that the variables that are constants don't exist, which is a little unusual. I can also see that here's the executables it drops and it plays with the kernel. There's a few things going on here. Queries the disk size, which is fine because it's installing something. Creates a temporary directory, which I'd expect. And as we scroll down, connects to various ports. It's got some drop files. What have we got here? DLL files, DAT files. So it's dropping all kinds of little files there. Touches files in the Windows directory. Interesting. Creates a mount point. So we can see quite a bit that's going on here. I also happen to know from digging a bit further through this that there is actually an executable file besides the installer that gets pumped out as well. But it's a bit odd because it doesn't actually contact DNS or anything like that. But everything adds up to saying, yes, this is malicious. Now, I happen to have done a bit of research and found out that the nullsoft executable self-extract version of files can be opened with 7-zip. You can't open them with WinRAR, you can't open them with PKZip or anything like that, but you can with 7-zip. So I'm going to open that up and have a look inside with 7-zip, open archive. Here we have a folder called plugins dir, and in that we've got some DLLs and a file called B. This file called B happens to be the right size of the original download for the original product. I'm going to have to pull that file out and see what it is. So if we now have a look at what came out of that file, we've got this file called B, and we've got a DLL and a DAT file. Now, I know from scanning this already that if I rename that B to .exe and I now run that, it's going to come up with VSDC free video editor. So this is the original file I intended to download. I didn't intend to get the DLLs coming along for the ride. If I go yes on that, it's going to go ahead and install as per the normal installation. So what's the deal with these files? Well, before we get into that, there's a bit more to the story here. When you've got a nullsoft self-extractor, there's actually a script behind it, and that script is obviously instructing what's going to happen with these DLL files, what's going to happen with the executable, and how it's all going to fit together. It's that script that tells us how this stuff installs in the system and what it does. So if you go up to the internet, you can find out more information. Here we have the universal extractor. The universal extractor allows us to pull out that script and have a bit of a look at it. Now, it can pull it out, unfortunately, as a encrypted file with the blowfish algorithm, which you're not going to decrypt overnight, that's for sure. But sometimes you get lucky, you get plain text. So let's pull out this script and have a look at it. So we go to the universal extractor we've downloaded, and we pull up the EXE file. Yeah, okay. It scans the file. It asks us if we want to output it, and away we go. So let's go and have a look at that output, shall we? Here's the output from the used Virustotal extractor. So we've got 2 bin files. Actually, we've got a 3rd bin file as well. This represents the first DLL file. This represents that DAT file, and this represents the script. If we have a look at this first bin file, and I just open that with Notepad++, we can see that it's got the magic byte MZ. We can see that it says this program cannot be run in DOS mode, so we know pretty much it's a PE style file designed to run in the Windows environment, and down here we can see the letters PE. So we do know this is either a DLL file, an executable file, or possibly even an SYS file. Looking at the second one, same deal, we've got the magic byte MZ, can't be run in DOS mode, and it's also a PE header right there. So again, it's an EXE file, or it's a DLL file, or it's a sys file. Open this one up. Completely different. This is the script file in binary format. If we scroll to the end, we start to see a little bit of what it gets up to. We get to see, it looks at the system time, we get to see a PHP being called on here, PHP, sorry, a website, girlsmist.online. That doesn't look good. I can also see that it runs some kind of an executable here, which is rather interesting. In fact, you're starting to see a little bit here of the script behind this, and it's looking a little dangerous. Now, it is possible to decrypt this script.bin and get further information out of it, and for that purpose there is a place on the website where you can download a Python script to pull it apart. So here we are at the Nullsoft decompiler. This will decompile that script.bin file for us if it can. Don't forget, if it's been encrypted with the blowfish algorithm, it's never coming back from where it's gone. But this gives us the best chance of pulling it apart. So I've extracted out the Python script and opened up the command which starts the process. Basically, it's going to look for my sample in this folder that I've created, and it's going to run Python 2.7. It's going to run the script against this Python file and output it. Having run this already and knowing that the information that comes out to the screen is more important than the decompiled content that it extracts for you, I wrote a second little batch file which simply runs that command but to an output.txt file, so I can actually see what's going to happen. So here I have the example directory. I have sample 3. There's my script.bin file. Here's my output.txt. So when I ran that Python, this is what came out. This is basically a bit of assembly, a bit of strings, all sorts of stuff. As you start to scroll through this, it starts to make some sense. We skip all the assembly and get down to where it gets important. So down here we can see that it's got the plugin directory. It's renamed that B file. In fact, here's the rename command right there into setup.exe, so that it installs the program you intended to install. Tells you which version it is. Installs version 3. As you scroll down a bit further, you can see that it puts in the run once command to run something from your temp directory. That looks a bit nasty. And then it also plays around with some DLLs, and then obviously installs your program as you want, but it also runs that EXE file, which who knows what that does, probably related to the adware. And as you keep scrolling, you can see more and more and more about what it does. So it's done a pretty good job of decompilation there and told us pretty much what's going to happen when we run this particular executable. The actual final decompiled file, to me, is actually quite useless. Just going to open that up with Notepad++. As you can see, there's not much in it. That's why I captured what actually came out at the screen. Just so you have an idea of how this works. So I've got all the extracted files here. I've placed that file into that example directory. Here's the command to run. And basically this is why I captured the output, is because it comes up on the screen and you've got no chance to view any of it. So at this point, we've got our original vsdc.exe installer file. We've got some DLL and DAT files and bits and pieces, and we've got a script that seems to be maliciously running these things and exporting things out and doing things with it. So what's the next step from here? I want to look at those DLL files. I want to work out what they're all about and how they all work. What I can do is I can run a tool called CFF Explorer to open up any PE header file and have a bit of a look through how it works. So I'm going to start that program up. Here we have CFF Explorer. File, open. I've now got the files that I want to interrogate. So if I open up nsisdl.dll, it'll show me the header, exactly the same as what I see in PEID. I can see the individual segments in the DOS header. I can see the magic number or byte. I can see all the bits and pieces that are stored in the different segments of the header. As I scroll down, when I get to the file header, there is a special little flag here called characteristics, and I happen to know that when that has a value starting with 2, that is actually a DLL file. But you can cheat. Click here, and it will say the file is executable, it is a DLL. So this little characteristics thing here will tell you what type of file it is for you. And you can also, with this tool, you can go down to the hex editor, you can go down, and if it was compressed with UPX, you can decompress it. You can look at any of the resources and orders that what it uses. You can go in the dependency walker and you can see the different DLL files it uses. So straight away I can tell from this it's a DLL file, which I knew anyway, that's the name of the file, and I can tell any little secrets it's got. If I was to open up the DAT file, so I now have system.dat open, same thing, it's got a DOS header. Go into the headers, it all looks very much the same. Go into characteristics, click here, it's a DLL. So it's renamed .dat, but it's a DLL. Go back here and I see again that yes, it's a DLL, it starts with a 2. From here, I'm going to open it in Ghidra and have a bit of a look at this system.dat file because it's a bit suspicious. Okay, so I've got Ghidra open, and previously I have loaded this file in, so I'm just going to open that file up now for you to have a bit of a look. Open with Code Browser, and I'm going to go through and analyze it and get it ready to show. Today I'm not going to go through and show you decompilation and how to use Ghidra. You can look at one of my previous videos for that, but this is the system.dat file with the headers and things like that. So if we have a look at the segments for the headers, we've got the magic byte, so we know it's a executable or a PE header of some description. If we look a bit further down, we come across this, which indicates yes, we were right, it's a PE header. And if we go down to characteristics, which is the same place but in assembly format that you saw in CFF header. So here's the optional headers. Here's the characteristics. There's that number 212EH starts with a 2. That's a DLL file. So we know that this DAT file from CFF header, CFF Explorer, get that right, and also from Ghidra, they both agree with each other that this is actually a DLL file. Now, knowing that a DLL file is a library or dynamic link library of various functions called on by external programs, I expect there just to be a whole bunch of functions. Look at that, there's a copy function, there's all sorts of functions. Here's the entry function here. There's just lots of functions. We could probably go through the graph and we may be lucky in the right spot, and we're going to see just how many there are. So that's just drawing up now. And there's at least 3 functions there, but there's a lot more functions than that. Now, yes, you can go through this, you can decompile it, you can figure out what it's doing. You'll actually find probably in this case that if we go to search for strings, we're going to get a much better idea because all the names of the functions are here. We can see that it's looking for sizes, it's looking for how much virtual memory is probably free. We can see some encryption or decryption procedures here. Looks for the things that are allocated. We can go through and we can figure out basically what is inside this. We can see some DLLs it calls on there too. If you've seen my previous version of the Ghidra, the Ghidra video, you'll see you can also figure out what imports and exports it's got, and you can figure out what resources it uses. So you can go through this, and of course as you click on everything here, it gets decompiled over here. So Ghidra is quite good for pulling apart and finding out what's going on, and then from this you can probably figure out what the malware does. But it's much more useful to you if you know what you're looking for. So how about we load the nsisdl.dll file and the system.dat, which is really a DLL file, up into Virustotal. So here we are in Virustotal. We've got the nsisdl.dll file loaded up, and at the moment all we can see is it's a PE file of type DLL, and there's no viruses. So this is likely just the tool or the engine that is used by the self-extracting executable to run the script.bin file. So in itself, it's not malicious. The system.dat file, which is really a system.dll file, is also a PEDLL, and we can see here that your heuristics detection or trap mine is saying it's malicious. It's got a moderate malicious score. We can go into relations. We can see that it's got 10 parents that execute. We can also see all these text files and executable files it's related to. That's of interest. Hashcoin.exe. Starting to think this is a cryptojacker or a Bitcoin miner. Interesting. Just on that one little piece of text. So anyway, we've found out a little bit more about it. Now you can go back into Ghidra with the knowledge of what it does, possibly, find out a bit more about it. But from our previous hybrid analysis of the actual overall first executable I downloaded, there were some keywords of some key viruses and things it found. So looking those up, we can now tell from the downloader.murlo, which is one of the things we saw, what it does. And we can see it downloads, adds, it also creates a backdoor. So now that we know that, we can pull apart that executable and look for any ports that are being opened, any IP connections that are being made. And also on Malwarebytes, there is trojan.adload, which is again one of the things that the hybrid analysis found. And that tells us again it opens a backdoor and downloads ads, probably related to that really unusual web address we saw. So we now know this thing's going to give us ads, it's going to create a backdoor, it's probably going to open up a port. All of that stuff's going to happen probably around the same time, if not just before, we actually install the product we originally wished to download. So this is bundled malware. One of those things you should be asking yourself is, how did he look at this number under characteristics and know this is a DLL file? I happen to know that from research that I've done. Don't worry, these links will be in the description. Here we go. We can go to the PE file format, which is up on GitHub. It's listed under the Department of Defense, particular part of GitHub. If I scroll through this quickly, it talks about EXE files, DLL files, and system driver files. And as we scroll down, it goes through the different sections of the files, walks you through each of the different parts of these segments. And as you go a bit further down here, under characteristics, which is the same thing under CFF header, so there's, CFF Explorer, I'll get that right in a minute, is characteristics. If we go down underneath the characteristics and scroll down to the appropriate section, you'll see there image file DLL, or image file of type DLL, starts off with the 2000 number. That tells it that it is a DLL file. Now, if you want to go into it a bit deeper, you can also go to the Microsoft page, which has a lot more information about PE headers and things like that, and goes right into the different hex codes for the different segments. And if you really want to take it even further, you can go to the Malware Researcher's Handbook, and that will take you through, again, the PE header format, the segments, and all the rest of it. Talk about the DOS header, the COF header, all kinds of things, and it actually uses CFF Explorer and some of the tools that I use as well. So it fits right in with what we're doing here. So what have we got here? So you've seen me pull apart malware, you've seen me pull it down to its basic essential parts, but how do you find it in the first place? How do you stop it getting on your machine and progressing? Well, go check out the Virus Doctor. Without him, this episode would not exist. Go check out the Virus Doctor, and if you sign up for any of his courses, special just for you, MickeyJ15, coupon code, use it. Well, we've got a legitimate shareware or free version of a product that I couldn't find from the original copyright holder, who I found from an old versions website. I've downloaded a already packed executable. They've repacked it with the nullsoft self-extracting executable. They've used a script within that executable to spit out an exe file, some DLL files, and change things around. That goes up to a website, it downloads ads, it creates a backdoor, and then of course installs the program that I originally downloaded. I was able to determine this by going through finding out what the PE header was, which is the nullsoft self-extracting. I was then able to use the universal extractor to extract out the script.bin file. I was able to use the Python tool to then extract out the information about the script and how it installs, and that was quite an eye-opener. I was able to use Virustotal to confirm I shouldn't just double-click and run this. I was able to use hybrid analysis to find out what executables it goes off to. I used CFF Explorer to confirm one of the DAT files was actually a DLL file. I used Ghidra to confirm the same thing. I used Ghidra to do a text search, and I could see all of the various functions that we're going to fire off. And at the end of the day, determine that yes, this is malicious, and it's a good thing I didn't just double click it. But having said that, I've now got out safely the executable I wanted in the first place. I can now run that and get back on with my video editing. So this is why I call this an executable that's like a Russian doll, because you open up that Russian doll and inside is another Russian doll, and inside of that is another Russian doll, and you keep going until you get to the nugget you actually want. So with this pulling apart malware, pulling apart all these sorts of things, you've got to step through it methodically, you've got to step through it cautiously. Always scan each of the components that pop out and check it, and be prepared to learn a bit of Python, to learn about the various tools you need to use, and obviously use videos like this as an example on what to do. And I will put links in the description again to all the tools and all the websites that I went to. I would love your feedback. I'd really like you to subscribe. I'd like you to hit that bell so you know the next time I pull apart something, whether it be malicious or not. And I really would like some comments. Ask me questions about what I've just done, or tell me what you would like to see. Give me some ideas, and I'll keep this channel going and educating us all how to pull these things apart. Thanks for your time.